Good morning, Year 4. Hope you're all doing okay, and welcome to Wednesday's maths lesson on fractions. Could you have a go at the starter on the video for me first? It says Mel and Teddy are solving 6/13, add 5/13, add 7/13. And Mo says the answer is 1 and 5/13, and Teddy says the answer is 18/13. Who do you agree with, and explain why? So pause the video, have a go, and have a think about who is the correct one in that with that question. Okay, so I'm going to use a fraction strip to show the answer for this. So I've just made a big rectangle and I've just split it into about 20 equal parts. I haven't actually counted it, but all I'm going to do is pretend these are split into 13ths. So if I write that above it, then you'll be able to see. So each of these equal parts is 1/13. So if we have 6/13ths, let's colour in 6. Let's go for blue. 1, 2, 3, 4, 5, 6. So we know that's 6. Then we need to add another 5. So 1, 2, 3, 4, 5. And then we need to add another 7. 1, 2, 3, 4, 5, 6, 7. So now if we just add all these how many shaded blue shapes there are, we'll get the number as an improper fraction. So if we count them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, it would be 18 as our numerator, and it would be 13 as our denominator because they're 13ths. Okay, but we can also write it as a mixed number fraction. So that's when we need to work out how many wholes there are. So if that's 1/13, when we get to 13, that's going to be a whole. So if I count them again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So at this point, we have one whole because up to this point, it's 10/13, 11, 12, and 13/13, which is a whole. So after that point, it'll be 1 and 1/13, 1 and 2/13, 1 and 3/13, and so on. So therefore, we know that there's one whole because it goes past the point of one whole, and there's 1, 2, 3, 4, 5/13 extra. So therefore, they're both correct because Mo thinks the answer is 1 and 5/13, so he's written it as a mixed number fraction, and Teddy has written it as a improper fraction where the numerator is larger than the denominator. Either answer is correct, they've just written it in a different way, but hopefully the fraction strips help you to be able to see how they're both correct as well. So let's move on then to today's learning. So we're going to be subtracting fractions with the same denominators today. So we've looked at addition and adding fractions. Now we're moving on to subtracting fractions. So our star words are pretty much the same. The only different one is subtract because we've taken adding up and put in subtract. So let's look at this question together first then. So we have 4/5 take away 2/5. So what is similar and what is different about these two fractions? Now straight away I spotted that the denominators are different. No, sorry, the same. They're both 5, so therefore they are the same. And the numerators are different. So we have the same denominator, different numerator. Now when we subtract the fraction, it is the same process as when we add them. So because both of the denominators are the same, the denominator stays the same over here. So we know that even though we're taking away, the denominator is still going to be 5. So if we have 4/5 and we take away 2/5, we just do 4, take away 2. So 4 in your head, 2 on your fingers, count back 3, 2. So therefore it's 2/5. You could also use a fraction strip to help work that out. I'll pause the video and I'll quickly draw one for you. So I've just drawn a shape and split it up into some equal parts. So each part is worth a 5th. If we have 4/5, let me colour them in. 1, 2, 3, 4. So that's 4/5, and we take away 2/5. Oh, I don't know how to take them away. There we go. So I had 4, I just took away 2, and I'm left with 2/5. So hopefully that shows it a bit better as well. So it's the same concept as addition, but just with subtraction. So when the numerators are the same, denominators are the same, we keep it the same, and when the numerators are different, we have to still subtract them. So I'm sorry, these colours are not matching up to these numbers, so I just noticed that. I'm sorry about that. So just keep the denominator the same, and take away the numerators. So, I've just done that, so I don't need to go through that again, but you could always use fraction strip to help with any of these questions. It's useful to remember because you're able to actually kind of see it then, and you're able to see how many are left once you take away the fraction you need to take away. So moving on to our developed learning, we can also have a mixed number fraction. So we have 1 and 2/5 to take away 4/5. So what is different about this question now, and what is the same? So again, we have the same denominator. So the denominator is still 5, but now we have a 1 whole as well, and the numerators are also different. So could we use a fraction strip for this, or how about abstract? So with a fraction strip, if we know that each of these squares is worth a fifth, 1, 2, 3, 4, 5, that's going to be a whole there, because that's 5/5. So if we know we've got 1 whole and 2/5, we know we're going to be colouring up until the whole. 1, 2, 3, 4, 5, because that's 1 whole, and then 2 extra as well. Okay, and then we're taking away 4/5, so then we've got to take away 4 of those. Now I don't know how to make this white. There we go. So we're taking away 4/5 because so far we've got our 1 whole and 2/5. Now we're taking away 4/5. 1, 2, 3, 4. And then we just count what's left. So we have 1, 2, 3/5 left. Okay, so that's how we would work it out if we were using a fraction strip. You could also do it abstract, using the abstract method. So that is just looking at it through this and working it out. So the way I sometimes look at it is I convert it to an improper fraction because that's easier in my head to work out. So what you can do, if you know that 1 and 2/5 is your mixed number fraction, you can do 5 times 1 because you know that 1 whole is going to be 5 lots of 1/5. So 5 times 1 is 5, add 2. So you do the 1 whole times the denominator, and then you add on the numerator, and then that's your new numerator. So that is the same as that. That's just the improper fraction way of writing it. And then you can do 7/5, take away 4/5, which equals 3/5. So I'll go through that again. You times the denominator by the whole number, and then add that on to the numerator. Okay. So now it's your turn to have a go at them. So some of them you might need to convert. You can use a fraction strip to help if you like. So in your book you can draw one. Have a go at them, and then we'll go through them afterwards, and we'll go through the answers as well. Okay, let's go through them together then. So the first one, 12/7, take away 2/7. So let's say that each of these are 1/7. We're going to count 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we're just taking away 2. And then we'll be left with 10. So therefore our answer for that one would be 10/7. And if you did want to write that as a mixed number fraction, it would be 1 whole and 3/7. And you can work that out from the number line as well, because if you have 1, 2, 3, 4, 5, 6, 7, that's where your whole would be, and then there's 3 left over, so 3/7. Let me just quickly get rid of that, and then we'll go through the next one as well. Okay, so for the next one, we're saying that each part is worth a third, and it's 1 whole and 1/3. So we need to work out where a whole would be first. So we know a whole is equivalent to 3/3, so 1, 2, 3. So at this point is where our whole is. So we need to go up to there, and then it's 1 extra. So 1, 2, 3, and then it's 1/3 extra. And then we are taking away 2/3. So 1, 2. Ooh, I need to change the colour. There we go. And we're left with 2/3. So our answer for that one would be 2/3. And then finally for the last one, we have 1 and 3/5 take away something. Fifths equals 4/5. So this one's a bit trickier. You still should start, if you're using a fraction strip, with this number. So we need to work out where 1 whole and 3/5 would be. So it's out of fifths, so each part is going to represent 1/5. And we need to find out where 1 whole is. So 1 whole is going to be where 5/5 are, 1, 2, 3, 4, 5. So at that point is our whole, and then we need 3 extra as well. So 1, 2, 3. So 1 whole and 3/5, take away something equals 4/5. So we need to get from here, let me circle it in red. We need to get from here down to 1, 2, 3, 4 here. So we need to work out the difference between these two. So by doing that, we could just count down our fraction strip. So 1, 2, 3, 4. So therefore, this should be 4, because you know that 1 whole and 3/5, take away 4/5, 1, 2, 3, 4 equals 4/5, your answer. Okay, hopefully that made sense. That was a tricky one though, just to kind of give you that bit of challenge. So now it's time for you to do your mathematics. There is a challenge on the video, so come back to it if you want to have the challenge. Have a go at your mathematics. If there's any problems, let me know, and we can always go through it in the maths drop-in as well. So for those of you who want a maths challenge, here is the challenge, and I'll go through the answers with you in a minute. Okay, well done to those of you who had got the challenge. Here are the answers, and I'll quickly talk you through them as well. So the first one says Teddy eats 7/8 of a pizza, Dora eats 4/8. How much do they eat altogether? So the key word in that sentence is altogether. When questions have altogether in them, that tends to mean you add them. So therefore you have to do 7/8 add 4/8, which matches with this one. The next one, actually we'll go to the bottom one first because the middle one is the one that caught me out. Teddy eats 7/8 of a pizza, Dora eats 3/8 less. How much does Dora eat? So this one, you need to take away what Dora has eaten to work out how much is left. So if you know what Teddy's eaten and you know that Dora's eaten that much less, if you take it away, it will tell you how much she has eaten. So therefore, it's 7/8 take away 3/8. Now this one was quite a tricky one. It actually threw me off, so don't worry if you got a bit confused by it as well. So it says Teddy eats 7/8 of a pizza, Dora eats 4/8 less. How much do they eat altogether? So you have to add two numbers together, but you don't actually know how much Dora has eaten, because all it says is that she eats 4/8 less than Teddy. It doesn't actually tell you the amount she's eaten. So that's what you need to work out first. So we know what Teddy's eaten, and it says Dora eats 4/8 less. So what you have to do first is 7/8 take away 4/8 to work out what Dora's eaten. So once you've done that, you'll get 3/8, and then you're just adding them together, because then you've worked out how much Dora has eaten and you add it to how much Teddy has eaten to work out how much they've eaten altogether. It was a bit of a tricky one though, so don't worry if it did catch you out. Hopefully that's all okay. Nice short video today. Woohoo! Any questions, send them my way, or we can go through them in the drop-in as well. Thank you for watching, and I shall catch you all again soon.